So, hello everybody again. Thank you for joining us on this webinar. My name is Dimitris Argyropoulos and I am the NMR Business Manager at ACDLabs. Today's webinar is titled Cut Processing Time and Get Quality Answers from Your NMR Data. And our presenter is Arvin Moser. Arvin is a Senior Application Scientist at ACDLabs. He's been with the company for more than 15 years. He has a Master of Science degree in Chemistry from the University of Ottawa and a Bachelor of Science degree in Biochemistry from York University. We intend this webinar to have a duration of around 20 minutes plus another 20 minutes for questions and answers. So it's not going to take you longer than, let's say, 45 minutes in total. So without further ado, I will pass it over to Arvin.
Thank you, Dimitris. Hello all and welcome to the ACDLabs webinar. I'm your presenter, Arvin Moser. Today's topic is cut processing time and get quality answers from your NMR data. I do have a few slides to show you and then we can jump into the software with a live demonstration. A bit of background about ACDLabs. ACDLabs was founded in 1994. There are over 150 employees at the company. The headquarters is located in Toronto, Ontario, Canada. We also have sales offices in Canada, the UK, Germany, France, and China. We also have a global network of authorized distributors. All our software is developed in-house. This means we do not rely on other companies to build our software. We do have full control of the quality of all the software modules, and we do not have to compromise our customer requirements with third-party add-ons. Thus, we build tools our customers really enjoy using. We are also a privately owned company. ACDLabs offers two main platforms. The first platform is the Spectras platform for all types of spectral processing, analysis, and data management. And the Predictors platform covers the PhysChem and admin tox predictions. We offer full support of all major analytical techniques. This includes NMR, chromatography, LC-mass, GC-mass, infrared, UV-vis, etc. We do have ongoing collaborations with all the major instrument manufacturers. This ensures that we correctly import their data, and if they ever change their format, we have the latest version. We can and have integrated our software with all sorts of analytical instruments so that we can retrieve and manage the data. We can provide the facilities for total information and knowledge management in an efficient way. This helps lead to better support for making the right decisions in a time-efficient manner. ACDLabs started in the 1990s. We introduced one of our early software platform, Spec Manager. This came with the NMR Predictors. We later transitioned to the Spectras platform. That occurred around 2011. And then we added the workbooks. That's in 2012. We continue to add new tools, including ASV, which is automatic structure verification, CCV, combined and concurrent verification, UBV, unbiased verification, biosequence tools, etc. In this webinar, we're going to focus on NMR workbook and the biosequence tools. So we offer advanced processing software using our NMR Sync, and what it does, it allows you to process proton or 1D NMR data and 2D NMR data at the same time. We can report it and database it. NMR Sync allows from peak picking from one experiment to be transferred to the other experiments, right? And this will save you time from processing individual experiments. And you can also process from the 2D NMR and transfer it to the 1D and the other remaining 2D NMR experiments. We can generate a unified report. This includes 1D and 2D NMR data with the structure, metadata, multiple in journal format, all done with a single click. We can also database the experiments. We can also database to the NMR predictors. This helps to improve the accuracy of the NMR predictors. And because it's in a database, you can do structure search, substructure search, spectra search by peak picking, similarity to a spectrum, molecular formula, etc. I just want to cover a case where incorrect assignments are done and how the software can give you that assistance and guide you in case something goes wrong. In this example, you'll see an incorrect assignment here. So this is this multiplet is incorrectly assigned. And what happens on the structure, because we have 2D NMR data, there is a red arrow that appears, and that flags the user that something could be wrong. So green means things are consistent with the 2D NMR data. Red means something's wrong. The user can correct it, and you'll see the green appear and the red disappear. So this allows you to quickly identify the issue and rectify it. From peptides, we see a lot of peptides work in research and development and in the pharmaceutical products. We have specific tools for peptides now, and this helps researchers facilitate their work. You can see here that we do have a peptide here. And if I click, we support 3-letter notation. The green, by the way, indicates that it predicts well and is consistent with experimental data. And we also have single-letter notation. Right, so you have the option jumping between the full structure, 3-letter notation, single-letter notation. If you have any modifications, you can also incorporate that too. And we also have the assignments, and this guides you using the predictors. You'll see green indicates it fits well with the assignment, and black is just not fitting with anything there. So we're going to cover this in our demo. I have a slide here that we're going to jump to our demo, so let me just jump out. I'll jump to the software here. So I'm in Spectras Processor. Spectras Processor is where you will load your data. So I'm going to select my experiments here. I have 4 experiments and a structure. I'm going to select it from File Explorer. I'm going to drag and drop it into the Projects panel. This will import the data, check alignment, and it will also check for any solvents and identify that for you automatically. It'll also attach the 1D NMR experiments to the 2D. So let's have a look. We have our structure. By the way, the name of the folder comes from the name of the folder, the top level folder for that. So that's done automatically. So you don't have to rename it if you want to save some time there. So we have our proton NMR. We have our structure attached. We have our solvent identified. We have an HMQC in this case. We have an HMBC, and we have a carbon NMR. And you can see in the 2D, we have our 1D attached to the 2D axis. So when your data is loaded, you can click Auto Assignment, which is this green check mark here. This will peak pick, integrate multiple analysis, peak pick across all the experiments, and report back a match factor. The match factor is a value between 0 and 1. The closer to 1, the more consistent the data is with the proposed structure. So here we have a match factor of 0.92. We also have a table that supports, summarizes all the assignments and the peak picking. And from here you can create a report. I'm going to click the report button here. So we'll create a report in ChemSketch. And in here is a multi-page report. We have our structure with our HMBC correlation arrows on, done automatically for us. We have our date. We have our table, summarizing all our data. And we have more than one page here. Here says page 1 of 8, so we can flip through the different pages. We have the extension of the table here. And we have our proton NMR here. So here we have our metadata, our structure, our multiplets done in journal format, done for us. We have our proton NMR spectrum. We can create an inset using this button here. I'm going to highlight the region I want to create an inset for and expand it out. And so we have our inset and our full spectrum in the report. And we have some other data. We have our carbon NMR, our HMQC. We have our assignments from our HMQC here and our HMBC also. From here, you can create a PDF if you want. There's a PDF button. And I have a PDF already done here. And you could see that the same report, exactly as you see it in ChemSketch, is exported to a PDF format. So I'm going to jump back to Processor. So I'm right now in ChemSketch. You'll see at the bottom here, jump to Processor. So just to summarize what I did here, we loaded a set of 4 experiments and a structure. We pushed the Auto Assignment button. This did peak picking, integrals, analysis across, and assignment, reported back a match factor, and we created a report with this button. Why did we do this? Well, this is the fastest way to process your data, to go through 4 experiments. If you have more experiments, you could also include those and create a report. In addition, we also have database capabilities. I'm just going to highlight them, that they are available. You can build your own database and store this information so you could share it with other users, and so that you can search it using a structure, a spectrum, molecular formula, etc. So I'm going to take a step back now, and I'm going to show you some manual processing, and we'll go through those steps there. So there is an undo button here. This is this curved red arrow. I'm going to do an undo. This will undo to where we left off last before the assignment. And we're going to look at the aromatic region on the proton NMR. So I'm going to right-click, zoom in on this region. I'm just going to roll the wheel on my mouse just to decrease the intensity so you can see the structure along with the spectrum. And what you'll notice is when I come near a multiplet, this red box appears, and this indicates that the software recognizes there's a multiplet. And once you're inside this box, the red box, you can just click, and the software will peak pick. And you'll see it peak picked. It did integration below in red. And it also identified that this multiplet is a doublet, and it calculated a J value, a coupling constant of approximately 8 Hertz. And you'll also notice that at the bottom here, a table got populated with this row, and it's identified the proton shift here, the coupling pattern, and the coupling constant, but also put in here a carbon chemical shift. And why did it do that? Well, because there's an HMQC or an HSQC experiment in this case, it automatically does the peak picking across that 2D NMR experiment and identifies there's a correlation there, and it picks up the carbon shift and jumps to the carbon and picks up that shift also. So by peak picking on my proton NMR, it automatically peak picks on my 2D NMR and my other 1D NMR experiment and populates a table for me. And the point of this is to save you time from processing. In addition, it also does a prediction in the background. You don't see the predictor, but when I mouse over the header of that multiplet, you'll notice on the structure a green circle. I'm just going to show you again. A green circle highlights saying that this multiplet best fits with that atom number 13. And this is the predictors in the background, guiding the user in case they need some assistance in their assignment. So if they want to complete the assignment manually, you can just drag from the header to the atom 13, and that gets assigned. So here it says atom 13. It's green because it's consistent with the predictors. And also in the table, it populates a new column called atom number. That atom 13 is assigned to this multiplet. So let's go through some more here. Let's zoom in on these peaks here. So once again, if you're inside the red box, you can just click on it, and that'll do the multiple analysis. Another approach, which I refer to as a classic approach, is that you can also define the multiplet yourself. So if I hold down the mouse, and I like to pick up a little bit of the baseline if possible, and drag across, you'll see my integral start to grow, and there's this red line. Now I don't want to be too high, because then I'm going to miss some peaks. That's my peak picking threshold. And I don't want to be too low, because I might pick up something from the baseline. So I try to aim for something in the middle. When I release the mouse, it'll do the peak picking for me, the integration below. It defined it as an M because it's uncertain of what the multiplet is. And it also highlights what that atom is. So if I want to assign it to atom 14, which is the most consistent, because it's green, and yellow, atom 16 and 15 are yellow, means that it's on the fence. I could assign it to whatever I want. So if I make a mistake, intentionally make a mistake, you can see that the atom becomes red, and that indicates that it's not consistent with the NMR predictors. In addition, I'm going to show you one more thing here. I'm going to switch out of the structure mode, and I'm going to put on the correlation arrows. All right, this is this button here. I'm going to jump back to the full screen. And you're going to see this red arrow. And that red arrow is to flag the user that something is not right. It is inconsistent with your HMBC experiment, your 2D experiment. And so you can quickly see and identify that something is not right. So the user can make steps to rectify it, and that's what we're going to do. We're going to do an undo. We're going to undo the assignment. We're going to assign it to atom 14. And when we do that, you'll see a green arrow now between atom 13 and 14. That's coming from the BC, indicating that there is a correlation there between those two atoms. Finish off with this aromatic region. Pick number 15. And last on the aromatic ring, atom 16. Okay, so you can see all the correlation arrows that are consistent. There's nothing red. The assignment, the predictors are all green. And you can see it also in the table. And this indicates that we have a good assignment. So just to summarize what I did here, I did a manual step now. I did a manual peak picking. I did manual assignment. I checked the assignment using the correlation arrows to make sure if anything is inconsistent. I also checked the colors of the predictors. They're all green. That indicates that something is good, everything is good and consistent with the predictors. I also looked at the table to make sure everything is good. So this is processing manually. We covered initially automatic processing using the auto verified button. I'm now going to show you some tools for our biosequence tools for peptides. So I'm going to jump into File Explorer. And I have a project already created. So I'm going to drag and drop the project in here into my projects panel. Okay. And what's nice here, and a few of our users may not be aware of this, but you can load more than one project. In this case, I have two projects. I have the original strychnine project, and I have my oxytocin. In the oxytocin project, we have a proton NMR, we have our nosy experiment, our toxy, and our cozy experiment. Now, this is a peptide, so let me just make this a little bigger. You can see this. Let's turn off the correlation arrows. Now, for peptides, we can represent this using three-letter notation, and to do that, we have these buttons over here. So I'm going to click on this. This will switch from the full structure peptide to the three-letter notation, and we also have single-letter notation. So by just clicking on this, you can see the differences between the different representations of the peptide, and that's using these buttons right here. In addition, when I'm in three-letter notation, you'll also see in the spectral data table, the column, the atom number column, is represented by the amino acid. They're given a number, and the atoms are represented here. So here you have different, and so you have the amino acid, you have the corresponding protein that's assigned, and so that's indicated there. In addition, you also see it on your spectrum, and let's zoom in on a region here. We're going to look at the cozy experiment. You'll also see that it's represented here with these three-letter notation, also on the spectrum when you switch to three-letter notation. So from here, if you want to change the assignment or you want to overwrite the assignment, it's easily done from the 2D NMR. If you right-click, overwrite assignment. And now you get this red arrow or line that appears, and you'll see that glycine with the NH2 modification there is highlighted in green. And this is the predictors kicking in, telling us that is the best assignment for that particular correlation. So I can click on that. Now we're going to assign the F2 first, right? Because there's two chemical shifts, two proton chemical shifts. So we assign on the glycine by clicking on it first. It tells us which one from the list would you like. The green is the best fitting one, the proton alpha from the CH2. Click on that. We'll assign it as a CH2. And now it's going to ask us to assign the F1 chemical shift. And this is also coming from the glycine. You see the yellow highlight. Click on it again. And the yellow is coming from the NH group, the exchangeable there in the glycine group. And you have it assigned. So just to summarize what we did here, we looked at the buttons for editing the notation or the representation of the structure from full peptide to three-letter to single-letter notation. We also performed an assignment, and we overwrote the assignment, and we used the predictors to assign the glycine and from the F2 and the F1. And just to make an extra note here that you can also database this too. This is stored in the database as three-letter or single-letter. You have the flexibility to do that representation of the structure in the database. So I'm going to jump back to my presentation here and just have a few concluding remarks here. We offer fast and efficient data processing analysis of NMR data without compromising on quality. We covered synchronization of peak picking. That's using NMR sync. We showed the assistance with structure assignment for small molecules and biomolecules, right? Using that's the color coding, the green, the yellow, indicating if something is good or on the fence. We verified assignments using the industry-leading NMR predictors, such that you can increase confidence in the assignment of the structure. It's important to note that the NMR predictors have been refined for over 2 decades, and that's why we are the industry-leading, we offer the industry-leading tools in the NMR predictors. We created a report, right? We clicked on the report, and with one click, and we created a report. We also created an inset in the report, and we exported that to a PDF. And we briefly covered some tools of the live spectra, the knowledge management, that's the database tools. So this concludes our webinar. I just want to say thank you for attending. I do recognize a few names in our attendee lists. Thank you for joining. We will be hosting additional webinars in the future. You can also sign up to our various media feeds like Twitter. And we're going to put it back to Dimitris, and we're going to check for any questions. Thank you.
Thank you, Arvin. That was very informative, I think, for everybody. We already do have quite a few questions coming in. So the first question, Arvin, is somebody saying, I have your software, but I don't think I've seen the peptide functionality. Why?
Okay, so this peptide functionality or tools for the biosequence are available in the version of 2017. So it is in the current release, and you can access it from there.
Okay, and we do not require any extra license or anything?
Correct.
Okay. Now, the next question is, how does the software handle modified amino acids?
That's good. I've seen this a few times. People modify their peptides and they want to display it. So if you recall in my presentation and in the demonstration, I had a modification of an NH2 group that was added off of glycine. You can do that. The software will recognize the amino acid, and the modification will be extended out off the amino acid.
Okay. Now, we have a couple of questions about reporting. It's two questions. They are very related, though. So the one question says that sometimes some peak tables go out of the A4 format. And the other question is, how did you get the common assignment table in the report to fit within the margin of a page in ChemSketch?
So I'll answer the second question first. The margins of the table, to get that to fit, there is a checkbox in the template that allows you to fit to page, and that covers the width, and it also covers the height. However, when you have a large structure, you're going to have obviously a table that's going to span maybe more than one page potentially. So you can also do that in the template by adjusting the width and telling it to fit onto another page if you want. The other approach I take too is I choose which columns to show. I don't show all the columns. There's a lot of columns, so they may not all fit on one page because there's, depending on how many experiments you have, if you have rosy or nosy data, other experiments, they do add a lot more information to that. So I recommend, if you still have any issues around that, get in touch with us and we can show you how to adjust the table for the report.
Okay, there are a few questions about importing the structure. So I'm gonna read the questions, and I think, Arvi, you could answer all of them together. First question is, can you import ChemDraw structures to the ACDLabs? How do you import the structure separately? How to insert the structure in the process? And we see that in the structure you include the numbering of the atoms. How we could do that?
There's a few questions. All right. So the first question, importing ChemDraw files. We do support import of ChemDraw files. These are CDX files. We also support MOL, SDF, etc. I did a drag and drop of a ChemSketch file, but it's the same thing for ChemDraw and other formats, MOL files. You just grab the file, drag and drop it into the processor, and that will attach it to the project if you have a project open. I think that covers the second question, how do you import the structure? It's a drag and drop. The third question, which is how do you incorporate in the process? You have to drag and drop it into the project if you're working on a project. The project is obviously more than one experiment that are related to each other. You can also, maybe to add to that, you can drag and drop more than one structure or even a mixture too if you want. That is available. And the last question, how do you show the numbers on the structure? I kind of shown a little bit of it. When you click on the blue arrow on the structure panel, it'll bring up the full structure panel and you'll get a toolbar. And there's a number sign, or some people call it a hashtag. If you click on that, that will display the numbers on the structure.
Now the next question is, what do you do when the solvent or impurity peak interferes with the analyte of interest peaks?
Okay, that's a tougher situation. You may see it with water interfering with some of your aliphatic peaks. You can do a few things. There's a few options. You can create a dark region, which basically, dark region means that you tell the software that this particular region is not of interest. And so you could dark region the water peak, and the software says, okay, I will not use that in the interpretation. Now, if the water peak splits, for example, a CH2 peak from looking at a proton NMR, then the software will recognize, there's some tools now that recognize that that multiplet got split. And so that's something to look at if you try it on your software.
Now, the next question is, when you were assigning structures, there was more than one atom or amino acid that was green. Why was that?
Okay. So in cases where there's more than one possibility, you can try, the reason why is they're very similar chemical shifts are being predicted for both of them, so you get green for both of them. And so you can try one assignment. That's what I normally do. I do a bit of a trial and error. Unless you know or are familiar with the structure or some derivatives of it, you can assign one. See if it's consistent based on the 2D NMR data. That's using the correlation arrows. If it's inconsistent, then try the other one and see if that's a better match. So the point is that it's guiding you through the assignment, and it's proposing a potential, and in some cases more than one potential assignment, so that you're aware that there might be a different possibility. And it's important to explore these different possibilities so that you get the best assignment.
Okay. There is another question here. We've seen some of the atoms highlighted as green, some are red, and some as yellow. What does this mean? Does it mean anything in terms of how it correlates with the chemical shift, or what do the colors mean?
Yeah, so the colors represent how accurate the prediction is in relation to the experimental data. So you're going to, for a proton side, you're going to see green when the shift is between, the difference between experimental and predicted is between 0 and 0.3 ppm. You're going to see yellow on the proton if it's between 0.3 and 0.9 difference in ppm, and red if it falls outside of 0.9 ppm. So that's for proton. On the carbon side, it's 0 to 3 ppm is green for carbon shift difference. 3 to 15 ppm is yellow for carbon, and anything greater than 15 ppm, it's red. We also have other criteria for nitrogen, fluorine, and phosphorus too.
Okay. I see another question here. If you include an incorrect structure, does the system check the validity of the peaks with respect to the compound you included in your project?
So if you assign a structure, or I assume this is an automatic assignment, the software will check the validity of the structure and propose a match factor in return. So that match factor is how consistent the NMR data that you have currently in relation to the proposed structure. If it's way off, you're going to get a very low match factor. That'll be a value closer to 0. And if it is consistent with the available data, it will be closer to 1. And that's using the predictors also in the assignment.
Okay. I see here another question. Somebody who has a 90 megahertz spectrometer. Not clear if it's a very old one or if it's a desktop one. So our resolution is limited. Can the 2017 processor still yield accurate results?
So I've worked with a few clients. I assume it's a desktop. You can import the desktop dataset experiment and be a 1D, I imagine, although there's some 2D also. It does work. You could do assignment. Depending on the broadness of the peaks, that can impact a bit how much wiggle room you have in the assignment, but it does work. If it is an old instrument, we've done it. I even loaded my old data from 17 years ago, and it still works fine with the assignment. But if they are interested in exploring this further, I recommend contacting us, and we could do something online together.
Okay. Here is another question from somebody very observant, obviously. He says that they saw in the report that the prediction was neural net. Is this the only type of prediction algorithm we have?
Yeah, so the neural net is one of our algorithms for the NMR predictors. It's used frequently now, and it is the default because it is the fastest. It takes like less than 0.1 seconds to do a prediction. The original algorithm, the hose, we refer to it as the hose algorithm, it takes a little bit longer. It takes approximately 1 second. And so you have the option to change or toggle between the two. There's actually additional algorithms too. But most people are comfortable with the fastest one, which is the neural net, and that's what we generally use. And we do report that in the table so that people are aware that the neural net prediction was used in case they want to go back and check it and explore it further.
Now there is another question here, again from somebody very observant, obviously, or probably somebody who has a software. When he defines a multiplet and he sees the green grid line appearing for the position of the multiplet, how can we move this in order to manually center it?
Yeah, so when you do peak picking, let me explain to the audience here. When you do peak picking on a project and you have 1D and 2D NMR data, we use something called Gridlines. This allows you to line the correlations from the 2D NMR with the 1D and vice versa. So in cases where there's a bit of an offset, you could see this sometimes in an HSQC where the correlation is just a little bit off from the 1D NMR. The grid line will be off a bit, and you can correct it. There's two ways to do it. From the 1D NMR, you can just peak pick it and change it, or you can delete it from the 1D and then peak pick again. I find it easier to do it from the 2D NMR, and what you do is you'll see a box around the peak picking on the correlation. As long as you re-peak pick inside that box, it will shift the grid line to the new location. I know this is maybe a little bit complex to explain, especially to someone who's new to the software. But once again, I encourage you to contact us and we could explore it together.
Okay, here is another interesting question. Can you selectively share your projects with your research group?
So I'm going to assume sharing can be done either through the database. So if everyone has access to the database, you can database your project into a database, and that is probably the easiest way to share information with a large group of people, provided they have access to the database. You can save the project in the processor. This will save it as a Spectras file. So it's .spectras. And then you can, I don't know, use a USB, or they could access it through the network. And they can load it on their system, especially if you have global connections. They could be across on the other side of the continent, and they can access your data from there.
Okay. So you mean when you are saving on a shared drive or something?
Shared drive, or yeah, or in the database, yes.
Okay. Okay. Also, there are two related questions. I'm going to say both of them. How can you automatically add the assigned structured data you did to the prediction library, and how to add things to the prediction library? Maybe this is getting a little bit off topic, but we can probably talk about it for a little bit.
Sure. Okay. So I kind of briefly covered it with the button. There's a button called Database, and in that Database button, you can have the option of doing database to a database called Spectras DB, actually it's to the predictor database. And so by pushing that one button after you had done the assignment, you can push all your information to a predictor database and improve the accuracy of the predictors.
Okay. I don't see any other questions appearing. Thanks everybody for joining us. I hope it was a productive time for everybody, and we hope that you learned something. Looking forward to seeing you in our next webinar. And in the meanwhile, goodbye, and enjoy your holidays wherever you are and whichever way you celebrate.